Hello everyone, welcome to Site Programming channel. I am Nagmani from 2nd BTech, belongs to the branch Information Technology from Sasi Institute of Technology and Engineering. So I am here to submit the video assignment on graph coloring using backtracking technique given by Nageshwara sir. Now let us know how to color a graph using backtracking technique. Generally, we think that graph coloring is just coloring a graph with some colors, but here we have to consider a condition. So graph coloring is actually coloring a graph such that no two neighboring or adjacent vertices must have same color. It means two neighboring or adjacent vertices must have different colors. For better understanding, take an example. Here A and B are adjacent to each other, hence they have different colors, and B and D are adjacent to each other. So they also have different colors. For coloring a graph, we have to keep in mind that two adjacent vertices or two neighboring vertices must have different colors. Applications of graph coloring. Map coloring and image segmentation. By using graph coloring, we can easily color a map so that it is easy to identify two different neighboring places or countries or states by their colors without any confusion. Now take a look on the term backtracking technique. Backtracking is an algorithmic technique where the goal is to get all solutions to a problem by going back along a path that you have just followed. So, to get all those solutions of a problem, we have a design called state space solution. So, the state space solution of a problem defines all possible states that the problem can be in. Let us discuss the design of state-space solution for coloring a graph using backtracking technique. I am taking a graph. So this is the graph I have taken. As we learned before, graph coloring is all about coloring the vertices of a graph. So here the graph I have taken before. Firstly, we have to make a list of adjacent vertices of this particular graph. For vertex 1A, that is, for this vertex, adjacent vertices are B, D and E. Similarly, for vertex to B, adjacent vertices are A, C and E. Similarly, for vertex 3C, adjacent vertices are BDE, and for vertex 4D, adjacent vertices are ACE. For vertex 5E, adjacent vertices are ABCD. If you observe here, for vertex 5E, there are 4 adjacent vertices. That is, all other vertices are adjacent to this vertex E. That is, we have to color the vertex E that should not match with any of the colors of A, B, C, D. That is, the color we give to the vertex E should be unique. Let us assume maximum colors for coloring this graph as m equal to 3 colors. I have taken these 3 colors as red, green and blue. I am designing a state-spaced solution which we learned before. If I am going to color the first vertex with red, that is, I am considering for coloring the first vertex with red. So if I colored this vertex with red, is it possible to color the second vertex is also with red? No, it is not possible, right? So second vertex cannot be colored with the same color that is used for first vertex since these two are adjacent to each other. So let's check for another color which is green. We can color this second vertex with green, right? So we are going for the third vertex. So if second vertex is colored with green and first vertex is colored with red, is it possible to color the third vertex with red? Yeah, it may possible, right? So third vertex can be colored with red. If it is colored with red, is it possible to color the fourth vertex with also red? No, it is not possible. So the fourth vertex cannot be colored with the same color which is used for third vertex because these two are adjacent to each other. So check for the another possibility which is green. We can color the fourth vertex with green, right? Yes. So for fifth vertex, is it possible to color the fifth vertex with red? No, it is not possible because we have already used the red color for 1 and 3. So it is not possible. Or is it possible to color the fifth vertex with green? It is also not possible because it is very adjacent to the fourth vertex. So, or is it possible to color with blue? Yeah, it may possible because the blue color is not repeated in any of the other vertices. Right? So here we got one solution in which way we can color this graph. That is first vertex with red, second vertex with green, third vertex with again red, fourth vertex with again green and fifth vertex with blue. As I told you before, the fifth vertex color should be unique. That is, it should not match with any of the other four vertices colors, right? So in this way we got this one solution in which way we can color this graph. So we have to go back to the third vertex. That means we have to use backtracking technique here for checking another possibility. So go to the third vertex. So here we have to check that red color is done, green color is done. Can we color the fourth vertex with blue? Yes, we can color it because the blue color is not repeated in any of the vertices colors. So we can color the fourth vertex with blue. Is it possible to color the fifth vertex with either red, green or blue? No, because these three colors are already used. So it is not possible. Hence, it is not possible to color the fifth vertex with any of the three colors. Again, we are going back to the second vertex. That is, we are using backtracking. Here, we are going with the blue. That is, with red we have already done. With green, we cannot possible to color the third vertex, right? Because it is adjacent to the second vertex. So we are checking for blue color. So for blue color, it is done with third vertex. So to color the fourth vertex, is it possible to color with red? No, because 1 and 4 are adjacent to each other. We are not again allowed to use the red color. So red is not possible. So is it possible to color with green? Yes, we can color it because 2 and 4 are not adjacent, right? B and D are not adjacent. So we are coloring the fourth vertex with green. So we are using green here. Is it possible to color the fifth vertex with any of these three colors? No, because the fifth vertex color should be unique. But red, green, blue are already used here. So it is not possible to color the fifth vertex. Again we are going back to first vertex. Backtracking to first vertex. Here we are done with red and we have already checked with green. So let us check for blue color. That is what happens if the second vertex is colored with blue. So if it is colored with blue, is it possible to color the third vertex with red? Is it possible? That is 1 and 3 are not adjacent to each other. So check for red color. If third vertex is colored with red, is it possible to color the fourth vertex again with red? No, it is not possible, right? So, but is it possible with green? We can color the fourth vertex with green, right? Okay, but is it possible to color the fifth vertex with any of these three colors? No, because all these three colors are used for other four vertices, so it is again not possible. Again we are going back to third vertex. We are done with green and now we are checking with blue. If the fourth vertex is colored with blue, is it possible to color the fifth vertex with any of the colors? Yes, we have chances, right? Because red, blue, only two colors are used for coloring four vertices. But again we have one color which is green. So we can color this vertex with green, right? So again we have got another solution in which way we can color this graph also. That is red, blue and green. Again we are going back to the second vertex for checking other possibilities. Is there any possibility to color this graph in any other way? Let us check. So green. We have done with red. But now we are going with green. If third vertex is colored with green, is it possible to color the fourth vertex with red? Is it not possible? Because first vertex is already colored with red. If we again color the fourth vertex with red, these two are adjacent, right? So it is not possible. Is it colored? Is it able to color with green? It is not possible, right? So it is not possible. So now we are checking with blue color. So here the fourth vertex is colored with blue. Is it possible to color the fifth vertex with any of these three colors? No, because there is no other color left. All three colors are used here. So again it is not possible to color this fifth vertex. Now we are going back to the first vertex. Here we got two solutions if we color the first vertex A with red. And the two solutions are, one is green, red, green and blue, and the other one is red, blue and green. And the graphs are these two. So in these two ways we can color the graph if we consider the first vertex as red. If we consider green for coloring the first vertex A, this is the state space solution that we have designed before if we colored the first vertex A with red, right? Yes. So in this case we are going to color the first vertex green instead of red. Let's see what happens, what solutions we will get. So first vertex is colored with green, right? Yes. If it is colored with green, we can color the second vertex with red. So we are coloring it. Yeah. It is colored with red. Now since it colored with red, third vertex should not be colored with red, but it can be colored with green, right? Since 1 and 3 are not adjacent to each other. So we are going to color the third vertex with green. After coloring the third vertex, we are going to color the fourth vertex with red. Because 2 and 4 also not adjacent to each other, here we can see that B and D are not at all adjacent to each other. So we can color the fourth vertex with red. So we are coloring it. After these four vertices are colored, we can clearly observe here these two colors are enough for these four vertices to be colored. So now we have another unique color for the fifth vertex, that is blue. So we can happily use it here. So fifth vertex is colored with blue. This is the solution, that is, this is the way in which we can color the graph if we consider the first vertex as green. Now backtracking. Let's backtrack to the third vertex. In this third vertex, we are done with red. Now we are not going to color the fourth vertex with green because it was already completed with third vertex. So now we are considering with blue. If it is colored with blue, then no other color is left for the fifth vertex. So it is not possible to color this fifth vertex. So now we are again backtracking to the second vertex in which green color is already completed. Now we are going to consider blue color for the third vertex. Yeah, third vertex is colored with blue now. Now the fourth vertex is to be colored with which color? It can be colored with red because 2 and 4 are not adjacent to each other. So it can be colored with red. After coloring the fourth vertex, there is no other color left for the fifth vertex. Since all these three colors are completed for these four vertices, so there is no other color left. So it is not possible to color the fifth vertex. Okay, again we are backtracking to this third vertex. Here we are done with red, right? Can we able to color this fourth vertex with green? It is not possible because 1 and 4 are adjacent to each other and one is already colored with green. Is it possible to color the fourth vertex with blue? No, because already third vertex is colored with blue. So there are no other possibilities for this third vertex. So backtracking to the second vertex. Second vertex is also we have no possibilities. Again backtracking to the first vertex. For first vertex, we are completely done with this red color. So now we are considering green. Can we able to fill this vertex to with green color? No, because these are very adjacent to each other. So it is not possible for the second vertex to color with green. So it is not possible. After red color and green color are done, we are going for blue. Now after coloring this second vertex with blue, we can able to color the third vertex with red. Now are we able to color the fourth vertex again with red? No, it is not possible. Can we able to color it with green? It is also not possible because 1 and 4 are adjacent to each other. So we are also not able to color with green. So but we can fill with blue, right? So we are coloring with blue. After coloring with blue, here we can see that three colors are completed for these four vertices. So also here no other color is left for the fifth vertex. So it is not possible to color this vertex. Now we are backtracking to the second vertex. Here red color is completed. We are going to color this third vertex with green. Yes, after coloring this vertex with green, is it possible to color the fourth vertex with red? Yes, we can color it. So red color is used here. So if this color is used here, then all these three colors are completed. So here also no other color is left for the fifth vertex to be colored. So it is also not possible. Again we are backtracking to this third vertex. For this third vertex, we are done with red. Can we able to color the fourth vertex with again green? No, it is not possible. So we are going with blue color. That is, we are going to color this fourth vertex with blue. So we have colored it. So here we can clearly see that only two colors are enough to color these four vertices, right? So we have another unique color that is used to color this fifth vertex, which is red, right? Yes. So we can use this unique color to color this fifth vertex. Here we got another solution. We can see that green, blue, green, blue and red. So in this way also we can color this graph by considering the first vertex with green. So here we got two solutions. As we seen before, we got again two solutions. If we color the first vertex A with green, and the solutions are green, red, green, red and blue, green, blue, green, blue and red. And the graphs will be like, so in these two ways we can color the graph by considering the first vertex as green. If we consider blue to color the first vertex A, this is the state-space solution that we have done before. That is by considering the first vertex with red in one case and by considering the first vertex with green in another case. Now in this case we are going to color the first vertex with blue. If it is colored with blue, now we are able to color the second vertex with red. If the second vertex is colored with red, it is not possible to color the third vertex again with red, right? So we are going to green now. After the third vertex is colored with green, the fourth vertex can be colored with red because here 2 and 4 are not adjacent to each other. So we can color the fourth vertex with red. After it is colored with red, there is no other color left for the fifth vertex where it should be unique. So it is not possible. Now we are backtracking to the second vertex. Because for the third vertex, red color is completely done. So after the red color, green color is not possible to color the fourth vertex. And again blue is also not possible because here 4 and 1 are adjacent to each other. So we are directly backtracking to the second vertex. Here green color is done, that is green is already colored. Now we are going for the blue. So here third vertex is colored with blue, right? So now the fourth vertex cannot be colored with blue again, right? Because 1 and 4 are adjacent to each other, but it can be colored with red because 2 and 4 are not adjacent to each other. So we are coloring the fourth vertex with red. Yeah. So here we can see that only two colors are enough to color these four vertices, right? So there is another unique color which is used to color the fifth vertex, that is green. Means here green is unique color in this particular case. So we got one solution in which way we can color this graph by considering the first color as blue. Now we are backtracking to the third vertex. Here it is completely done with the red. Now we are considering green. Here the fourth vertex is colored with green, right? Now all the three colors are completely enough for this four vertices. So there is no other color for the fifth vertex. So it is not possible. Now backtracking to the first vertex directly. Now we are considering green. Because red color is already done with the second vertex. Now we are going to color the second vertex with green. Yeah. So if it is colored with green, now we can color the third vertex with red. After coloring the third vertex with red, it is not possible to color the fourth vertex again with red. But it can be possible to color the fourth vertex with green. because 2 and 4 are not adjacent. So we are coloring the fourth vertex with green. So again there is no other color left for the fifth vertex, so it is not possible to color the fifth vertex. Now we are backtracking to the second vertex because for the third vertex it is not possible to color with blue because 1 and 4 are adjacent to each other. So we are not going to consider blue here. So we are directly backtracking to the second vertex. Now we are going to color this third vertex with blue because green is not possible. Red is already done. So we are going with blue. Yeah, we have colored the third vertex with blue. Now, is it possible to color the fourth vertex with red? Yes, it is possible, absolutely. So we are coloring it with red. After coloring this vertex with red, there is no other color possible for the fifth vertex to be colored. So it is not possible. So backtracking to the third vertex. Third vertex is colored with blue, right? And the fourth vertex is colored with red. So red color is completed for the fourth vertex, and we can color the fourth vertex with green because here second vertex is colored with green, but 2 and 4 are not adjacent to each other. So we can happily color the fourth vertex with green. Yeah, we have done it. After coloring this fourth vertex, we can clearly observe here that two colors are enough for these four vertices to be colored. So we have another unique color which is red that is happily used to color this fifth vertex. Yeah. So we can see that red color is used for the fifth vertex. So this is another way for this graph to be colored by considering the first vertex with blue. So again we are backtracking to first vertex. Here we are done with red color, green color. Now we are going to consider another possibility for the second vertex, that is blue. But we can say that these two are very adjacent to each other, right? So it is not possible. Again in this case also we got two solutions, and the two solutions are, first one is blue, red, and green, and the second one is blue, green and red, and the graphs will be like. So in these two ways we can color the graph if we consider the first vertex as blue. Therefore we can color the below graph with maximum of 3 colors in 6 different ways, and the 6 ways are, and the graphs we have colored by using backtracking technique are, in these 6 different ways we can color the graph we have taken with maximum of 3 colors by using backtracking technique and state-based solution. If you have any queries in this video, you may raise your doubt in the comment section. Thank you.